Hi everyone. One of our most popular little applications used around the world is actually TX line. I'm going to give you a little demo of it right now. The reason it's so popular is, first of all, its application is wide and varied. You can see it right here. It's used anytime you have lines in microwaves or RF. So you can see the various technologies, microstrip, strip line, CPW, etc. We're going to focus on microstrip for simplicity. Incidentally, the way to get to it in our software is I have my software over here in the background with a schematic in front of it. But if you go to Tools, TX line is right at the top. So just click on that and it will come up for you. The reason people want to use this, for example, might be we want to know what the width of a line needs to be 50 ohms. Or how long does that line need to be 90 degrees at 8 gigahertz. And these are the kinds of things TX line can answer for designers. Let me show you a very simple example here. On my left in the schematic, we have a microstrip line, an M-line. This would be a line over a substrate with a perfect ground below it and air above it. And here in this M sub is the thickness of the substrate is 1 millimeters. The dielectric constant is 3.38. And our designer here wants to know how wide should that line be to be a 50 ohm line. And the brutal way to do this would be to go in and incidentally and start sweeping the port impedance. This makes it much easier. So I come over here to TX line, I pick microstrip. I've filled in a number of these fields already, but I'm sure you can see how I did them. The dielectric constant I filled in as 3.38 based on the M sub. I'm not going to worry too much about the conductivity and the loss tangent. They won't affect it very much. Now these two boxes on the bottom, the left one is electrical characteristics. What's the impedance of the line you want? At what frequency do you want the length, in this case, to be 85 degrees? On the right side are physical characteristics. What's the length of the line, its width, its height, its thickness? That would be the metal thickness. By clicking these two arrows, you can go back and forth so that you get the side you click to corresponding to the other one on the other side. And we'll do this with our width in a minute. Notice my units here I can change. Right now they're in millimeters because, of course, that's what we're in. You could, for example, use microns or mils if you so desired. So what I'm going to do here is on the left I wanted 50 ohms, and I'm not too worried about the quarter wavelength, etc. And I notice here on the right the height is 1 millimeter. Here at the top, dielectric constant 3.38. I click the right arrow and it's telling me I need a width of 2.37 millimeters, which I come over here to my line. I've already put it in, but in general I would type it. And I go ahead and simulate. And look what we have sitting right here in the middle of the Smith chart. S11 is 0. It's a 50 ohm line, 50 ohm ports. There's no reflection. So I hope you find it useful. As I said, it's one of our most popular features, little apps in the world that people use. And have a good time using it. Talk to you later, everyone. Thank you.